This is Chase Nicholas again with the project Automated Testing of NHC, National Hurricane Center Forecast Accuracy. In the previous presentation, I introduced the research question and how the script helped solve it. And in this presentation, I'm going to actually run the code and explain a little bit more about how it works. So first off, here's the template map that's provided in the project folder. The toolbox containing the NHC forecast test script is within the code subfolder in the project folder. So here's the GUI for the NHC forecast test script. It contains just 4 parameters and an explanation for each one on the right as you go through. First, it asks the user for a storm year, which is constrained to years since 2015. The NHC's online data storage for previous years was less organized, so it didn't make sense to go back any farther for the purpose of this project. Second, it asks the user for a storm name. This one is text only, but it's not constrained. I think ideally it would be obtained from a dictionary keyed with storm year and a data validation tool, but that wasn't part of the scope of this project either. So instead, this code will just reject any storm names that either don't exist or don't match the storm year based on the online archive in the URL. And finally, the GUI asks the user for a grace period, which I'm going to explain in a minute, and a workspace where the files will be stored. Jumping back over to the slides, I mentioned that much of what this script is doing is just downloading data and extracting it. So this is actually a great use of the Python batch processing because all those forecasts are saved in individual zips on the NHC's website. And it takes some drilling to get down into the website of the right files, but once you do, it's much easier than downloading them all by hand because there's often 50, 60, or 70 forecasts. And this is just what that directory looks like online. So after the script has obtained all the necessary data and extracted it, it begins this loop within a loop of geoprocessing that actually happens pretty quickly. Essentially, for each forecast, the actual storm centers that were measured that fall within the forecast window, that 5 days for which the forecast is valid, those are identified and they're tested for spatial membership within the forecast area. Ultimately, that allows the script to identify inaccurate forecasts and add them to the map. And just to show a little bit why the grace period is important, you can see this point over here, which is actually included in the 5-day window for this forecast, but clearly occurred before the forecast was published. So jumping back over to the script, I'm going to go ahead and run it from inside ArcMap with the defaults running it on 2017 for the storm Fernanda and a grace period. I'll increment this up to 5 just to be super careful. My workspace is just C. It's downloading the forecasts now. We know there's going to be 36. I used progressors to update the user. It extracted forecasts. It's grabbing the best track, those measured centers, and extracting them. And now it's testing each of the forecasts. And it's going to spit out a little report for us with the total number of forecasts, the percentage that were accurate, and a storm test result that shows it passed the 60% threshold. It also automatically added all of those inaccurate forecasts to the map as well as the best track points. And you can see that all of the data is stored now in that workspace where I told it to go, along with a version of the map that is saved, and it essentially just has, I'm just going to open another instance here, but essentially just shows this kind of at a fixed point in time. So thank you.